Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. Okay, so we are now in the last part of this chapter, position, displacement and level sensor, which is we are on the optical sensor. Okay, so we already discussed about the potentiometer, and then capacitive, inductive, magnetic, and last part is optical sensor. Okay. Okay, so optical sensor is one optical sensor popular for measuring position and displacement. Besides the other sensor we already discussed before. Okay, why? Because they are very simplicity, so the absence of the loading effect and relatively long operating distance, so which is they can operate in long distance. Okay, it's insensitive to stray magnetic field and electrostatic interference, which make them quite suitable for many sensitive application. Alright, so the in optical sensor, there needs at least three essential components. First, they needs a light source. Alright, so of course they need a light source, and then second, it needs a photo detector to detect the light, to detect the wavelength or intensity, and then lastly they need a light guidance device, which may include lenses, mirror, optical fiber and others. Alright, so in optical sensor, they are based on two mechanisms. Okay, so if you can look at this figure, this is okay, so if you can see from this figure, there is emitter and receiver, which is light will be transmitted from the emitter to the receiver, and then any changes of the characteristic of the light, such as intensity, wavelength, polarization or phase, by the physical parameter will be monitored. Okay, so they are there will be the light will be what we call as it will flow from emitter to the receiver, so the receiver will be detect any changes on the physical of the lights. Alright. Okay, the second mechanism which is when the transmitted light is reflected from the object and light returned towards the source is monitored. So means that from the same object, which is light will be transmitted from here to the object, and then from the object the light also reflect to the emitter, which is the emitter and photodetector will be in the same casing. So they here inside this one there will be emitter and also photodetector. Alright, so any changes of the reflected light will be monitored, such as the intensity of wavelength. Alright, so one of the example of the optical sensor is the fiber optic sensor. Okay, so fiber optic sensor, it can be used as a proximity and level detector. One example of displacement by using fiber optical sensor, you can see from this figure, which is we have an optical fiber, which is we have optical fiber, right? So where the intensity of the reflected light is modulated by distance d to the reflective surface. Alright, so we have light from the optical fiber, okay, passing through, will be transmitted from the optical fiber to the sample. Alright, and then at this here, from here they will reflect back into the optical fiber. Okay, so if we have some more distance here, so this one is D and this one is the D apostrophe, so the value of displacement is different, right? So maybe if the light is reflect from here, the intensity will be large compared to the intensity that reflect from the other displacement. So the different value, this one will indicate the value of displacement. Alright, another one example that use the fiber optic sensor. For example, this one it used for detect liquid level sensor. Alright, so how the working principle of this one is, we have two fiber, which is one is the emitter and another one is as a photodetector. Alright, so this one is emitter and this one is a photodetector. Okay, so how they are detects, it's utilized by utilize the difference between refractive index of air and the measured liquid. Okay, so when the sensor is above the liquid level, for example like this figure, okay, so a transmitting fiber will send most of its light to receiving fiber due to a total internal reflection of in the prism. Alright, so light passing through from here to here, okay, and then they will be wrong light. So light from here, okay, when they reach the prism and then reflect due to the total internal reflection back to the photo detector. Alright, okay, so some of the light will be at the surface of the prism. There will be when the angle surface at angle which is less than angle of total internal reflection, they will lost to the surrounding. So here is due to the where the angle on the surface is less on the angle of the internal reflection, they will lost to the surrounding. So this is the situation. Alright. Okay, what happened when our sensor, our optical fiber inside the water level? Okay, so if you look at the right figure, right, so when the prism reach the liquid level, the angle of total internal reflection will be changed because the refractive index of a liquid is higher than of air, right? So this result in much greater loss in the light intensity, which can be detected at the other end of receiving fiber. So means that if there is so much loss, so here, right, if you can look at this figure, the ray of this one, they are so much loss when the sensor is inside the water level. Okay, so the indication of the loss will make a measurement of the distance. So it means that when we the sensor at more deeper, again there will be a lot of losses of the light compared when they are at the above of the water level. Okay, so that's how the displacement, the optical sensor make a measurement of the displacement and the level and the water level. Alright, so that's all for this part. Okay, thank you. So before you end of this chapter, you need to record your attendance on the QR code that I will be given on the Google Classroom. Alright, that's all. Thank you.